Hi.
Hello, Haripriya.
Why didn't you take the classes today?
Yesterday, actually, this I was telling you, na, my laptop was not good. So yesterday I had planned to go there to repair it. He has taken, I have given him the laptop 3 or 4 days before, and he was telling me, sir, the motherboard has to be changed. So that's why yesterday I went in the morning at 1 p.m. 1 p.m. and then after it took so much time for him to repair. From 1 p.m. I was waiting there at the shop till evening 7:30. He was repairing the motherboard, and ultimately he could not do it. He had to replace the motherboard. So that was actually, I thought by the time your class timing will be there, I'll come here. I'll come to home and then I'll take your classes. But it was not possible for me to come home. That's why I could not take your class. Now it's done. Now it's repaired. Motherboard, he has changed the motherboard. Now it's old laptop only. That's the problem. I was telling you, my laptop was not good. It's broken.
Yes.
From last 3 or 4 days, actually, how I was taking your classes, na? In the morning, I was not able to take morning classes from last 3 or 4 days. Means what used to happen, my brother, he comes from office in the evening, so I used to take his laptop. I have installed everything there, this Zoom and everything. And when he comes back, I am able to do the classes. But now on that day, I thought the morning he will be. I had talked to him before that will you be able to repair. He told me, sir, you come. I'll just. It's only just few minutes or few hours, 1 or 2 hours at max. We'll take and then we'll repair the motherboard. Otherwise we'll replace the motherboard. I said okay. Then I will be able to take the class in the evening. But he was keep on working, and then when he went to bring the new motherboard, it took 2 hours actually, 2 or 3 hours. I was really exhausted. And the place is named as the Asia's biggest market. You may be knowing Nehru Place. Nehru Place is a place in Delhi which is supposed to be the biggest market in Asia for the electronic goods, especially for computers. In nowhere else you will be able to repair your motherboard and all. My laptop is Core i5 10th generation. And now after that, few generations have come. And usually to get the motherboard, it's not easy. I mean, sometimes we get, sometimes not. That's the problem. Otherwise, I've thought of if he is not able to do it, I'll buy the new one so that my classes do not get disturbed. Okay, so what we were doing, gravitation potential we were doing. Diva has exam tomorrow, so she will not be able to join. Let's start. What is gravitation potential? See, the term potential that you see here, it's associated with the with conservative force field. That's why they say, see, a wise advice that I would give you to all, whenever you buy laptop, I means over the period I'm using the laptop and desktop computers from my engineering days. What I have found out, if you want to buy a laptop for your use, identify what your use is, then buy accordingly. Just understand how much amount of power and processing you want, because the cost of laptops and these desktops, they go very high. You see how much is required, and it happens you will think that I will buy the most powerful and fastest laptop and it will be more expensive, so the it will work nicely. The problem is when it will be broken now, means it's not working, then more complex the laptop is, more complex your technology is, more difficult it is to repair. That's the problem. And you will see that there will be service centers, or there will be service center service. The service support they provide is only for mostly for up to 2 or 3 years, and usually the problem in the laptops and all, they arise after 3 or 4 years of continuous use. Then you have left only with one option to buy the new one, and with that your work also gets disturbed. From now on, after few months, what I will do is I'll keep two devices. One gets broken, I'll take classes from the other one. If that gets broken, I'll take classes from this one. Like this I'll do. See what was there? You have understood now? For you guys, there's no problem. You can watch classes from this one also. Tablets and all. Phone also. Gravitation potential, what it is? Gravitation potential is the conservative force field. See, what I was telling, the term potential is associated with the conservative force field. And what is a conservative force field? Do you know? Do you remember? Electrostatics and gravitation are actually both same. Gravitation potential is a conservative force field. Gravitation force, this is conservative force. See, what I was telling, the potential is actually associated with the conservative force field. Conservative forces, as you know, is electrostatics, that you will learn in class 12. And the other thing is your gravitation. Other is spring. The thing is, see, sometimes they say electrostatic is necessary to understand gravitation, but it's not so. Because why? See, if you are learning gravitation from the scratch, you know the gravitation from the scratch, then you will comfortably understand the electrostatics in class 12. If you know the electrostatics in class 12 and you have not studied gravitation in class 11, you will understand gravitation in class 11. Why? Because they are exactly same. Okay, they both are exactly same. So now let's talk about the potential. So what I was telling, the potential is related with the gravitational force field, is conservative force field, and you may be knowing the terms. In the gravitation, there is potential energy like mgh. In electrostatics also you will see it's minus q1 q2 by 4 pi epsilon naught r. Later you will learn in class 12. And the gravitation also, what is this? Why it is hanging? Minus g m1 m2 by r, this we will be learning. And spring forces of potential energy is half k x square. But now let me explain you what is a gravitation potential and potential energy. What is gravitational potential energy? It is defined as the negative of the work done in bringing a mass from infinity to that point. Okay, let us keep the mass of this as m1, and the dummy mass that we want to move from m2 from infinity to that point is this m2. So we want to find the potential energy, or the potential energy will find at a point P. That means what we are doing, potential energy of the system, that means potential energy is the negative of the work done in bringing a mass from infinity to this point. Understood? Haripriya, okay? Kanishka? You're able to hear me or not?
Yes, sir.
Yes, sir.
Okay. It's the work done bringing a mass from infinity to r. It's the negative of that. So how we'll calculate? Suppose there is a mass m1. The force on m2, if it is kept at a distance x from it, will be g m1 m2 upon x square. Now what I have done, I have displaced this mass m2 by a distance of dx. So the work done on this m2 will be, for the displacement dx, the work done will be f dot dx, which will be g m1 m2 upon x square dx. Right? Now what you are doing, you are actually, you have found out the work done for the displacement dx. Now you have to find out the total work done. So you have to integrate it from infinity to r. It will be g m1 m2 upon, from infinity to r, dx upon x square. m2 minus 1 by x. Okay. So minus g m1 m2 upon r. It's not negative, it's just different. So the potential energy at a point R is minus G m1 m2 upon R. The thing that I have done is just I have found out the through derivation. I have explained you through derivations. I have explained you what is the potential energy. Understood? It's the work done in bringing the work done in bringing a mass from infinity to that particular point at which we want the potential energy. Clear? Correct? Okay.
Yes.
Now the important thing is how to find out the potential. There is a potential also. There is a term that also I'll tell you how to. Now I'll tell you about potential energy of a system of mass. See, when I was telling you about the electrostatics, electrostatics is exactly same. Everything is same. If I compare electrostatics with gravitation, just the masses have to be replaced with charges, and minus G has to be replaced with 1 by 4 pi epsilon naught. Then every formula, every concept of this gravitation becomes the concept, every concept and formula of the electrostatics. My video is pausing. Potential energy of a system of mass. Now see here what is there. There are 4 different masses. One this, one this. Let me make a square first. This, 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 this. Why sometimes it hangs? There are four different masses. This is M1, this is M2, this is M3, and this is M4. Let's say this distance L1, this is distance, or I can write as R1, R2, R3 like that. R1, R2, R3, this is R4. Let's say this distance is R5. This is R6. Now, when you want to find out the potential energy of a system of mass, when you want to talk about the system of masses, you have to, when you want to find out the potential energy of a system of mass, you have to actually take the combination of 2 because you know only to find out the potential energy of a 2 mass system. So you have to make all the possible 2 combinations. See, if you have the knowledge of permutation and combination, if you know the combination things, what you can do here, you can take the combination of 2 means there are 4 different uh, objects. So out of 4 you can make how many combination? 4C2, 4 factorial by 2 factorial to 2 factorial, 3 into 4, 1 into 2, 2 to the 4. So possible 6 combinations, 6 2 combinations will make. So what's the trick? Make all possible 2 mass combinations. So what you have to do is all possible, total I have found out 6. What those 6 are? Minus G M1 M2 by R1. Have fixed M1, then taken all combination M1 with M2. Now M1 with M3 minus G M1 M3 by R6. M1 with M4 minus G M1 M4 by R4. Without repetition. 3 combinations we have made. Now we have done with M1. Now fix M2. M2 with M1 we have already taken, so no need to take it again. So minus G M2 M3 divided by R2. M2 with M4 is not done. Minus G M2 M4 by R5. Okay, M2 is also done. Now M3 with M1 is also already done. M3 with M2 is already done. M3 with M4 is done? No, it's not done. So minus G M3 M4 by R3. All 6 are done. So this is the potential energy of this system. I can write potential energy as minus G common M1 M2 by R1 plus M1 M3 by R6 plus M1 M4 by R4 plus M2 M3 by R2 plus M2 M4 by R5 plus M3 M4 by R3. Haripriya, Siva, understood?
Yes.
Mhm. This is actually very important. Oh, that's why it was not plugged in the power. I'm giving you a question on gravitation potential. You try to solve it. Here it is 1 kg. This is also 1 kg. This is also 1 kg. The length is 1 meter. Easy one. Try to find out the potential energy of these three mass system. You can give me the result in terms of G, capital G, or if you want, you can put the value of G also.
Minus 3G.
Huh?
Minus 3G.
Minus 3.
G.
Wait. G. It's very easy, I think.
Minus 3G.
Correct. Minus 3G is correct.
I was telling you the same thing.
No, I have heard. Is my voice breaking today? Or it's clear?
No, sir. I thought you didn't understand what I was saying.
Okay, let me give you some good question to you. Yes, try to solve this one. Wait, it's coming. What is this? Why it's not coming? Okay, let me send. You have the access to your WhatsApp, na? I'm sending the question on WhatsApp. It's taking time. Oh, it came here. Good. Now try solve this. Try to solve this one.
So is there no options?
No, there are no options here. You need to solve and get the answer.
Is it 28 m square by minus g of 28 m square by s square?
No, wrong. You have actually not taken those distances, na? You have not considered about.
The diagonals.
You have not considered about diagonals. These one, this one, and this one. Again, this one with that one. You have to consider everything.
So what will be the distance like the opposite diagonal?
Opposite. It will be
The
root 3.
the
Root
long
3.
one.
Hmm.
The diagonal.
Yes, see how you'll find. I'll tell you. This is A. See, this distance is A. Again, this distance is A. So this diagonal will be root 2A. Correct?
Yes, sir.
Now this is root 2A. This one is root 2A. The vertical is A. So this diagonal will be how
So it will
much?
be a square plus 2a square.
A square
3a
plus 2A square, 3A square. Root over that. Root 3A. Like that. The thing is, you have to make use of all the possible combinations. See, that's why I have told you. That's why I have told you. Here, the knowledge of combinations, permutation and combination helps. If they give you kind of complex questions, the permutation combination helps actually. There, you will be able to understand how many two mass combinations that you will be taking using combinations. Because see, how many masses are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 masses are there. So possible two mass combinations will be 8C2. Probably 8C2 means it should be 6, 7, 8, 2, 8, 28. Total number of systems you will have is 28. And of these, you have to find how many of them are long diagonals and how many of them are short diagonals. 1, 2, 3, 4 will be long diagonals.
What is the answer? Like,
Answer
minus 4gm square by a into root
answer
2
is
plus
minus gm square by a into
a.
12 plus 6 root 2 plus 4 by root 3, they are saying.
Or they have this. I got it, sir.
You got it?
Yes.
Because see, what's the trick here? Here, total 2 mass combinations are 28. Out of these, if I see 4 are long diagonals. 4 combination are long diagonals. It means root 3 distance. And 12 will be short diagonals. Meaning what of root 2a. How many left? 16, 18, 10, 12. 12 are left. Now these 12 will be your edges. Okay, then you'll get the answer. If you want to calculate, if you want to just see how many of them are there, how are these, you can just analyze by yourself. But since you've got the answer, you must have got it. Understood? What's the potential energy? How to calculate the potential energy? Kanishka, what about you?
Okay, sir.
This must be confusing for you, na?
Yes, it is a little bit confused.
But now you understood.
Yes, sir.
What I would recommend you to do after class, just try to see. I have how I have framed. I have totally found out total two masses combinations, because there are 8 masses. 8 C2 will be actually 28. So all possible 2 mass combinations will be 28. Out of which I have actually separated 4 are long diagonals, means were root 3. Like one is this, other will be this, other will be this, like that. Like that, 4 mass combinations are there. 4 long diagonals. No, 4, not 4 mass, 4 long diagonals. And similarly, you'll get 12 diagonals, 12 short diagonals, and 12 edge to edge. After this, let me tell you about the next concept. Next concept is potential energy is done. Now coming to motion of satellites. This is also a very important portion. From this portion also many questions are asked. Motion of satellite. Arey yaar. I did not explain you about gravitational potential. Na? I'll tell you about gravitational potential also. See, like field, you know, na? Like field, there is a potential. If you look for a 2 mass system, there is a force M1, M2. There is a force which acts, and that force, you know, force is Gm1 M2 by R square. If at any point, if I want to find out the field, what I want to do, I have to remove the mass present at that point. You have learned this all. You must be remembering. So the field at this point is E is equal to gm1 by r square. Correct? Right, Haripriya? Kanishka, you remember na this one?
Yes, sir.
If I want to find out the potential at the point of m1, sorry, field at the point of m1, what it will be? It will be g m2 by r square. Just we have to put, to find out the field at any point, what we do, we just put the mass present at that particular point as 1 kg. That's the concept of field. Now in the same way, when we have potential energy of two mass system, when we have potential energy like m1 is there, this is m2 is there, they are separated by distance r, we are trying to find out the potential energy. The potential energy is given by minus g m1 m2 by r square. For finding out the potential at any point, what we do, we just put the mass as 1 kg. Vp will be equal to mass m2 is equal to 1 kg we do. Like field, it's similar to field. It will be minus g m1 by r square. But the beauty of this is, when we find out the potential, we take the magnitude only. We are not concerned with the sign because potential do not have sign. Okay. And similarly, if we want to find out the potential at the m1 point, what we do? We put m1 as 1 kg. The potential, if I take it as q, potential at q will be gm2 by r square. Minus sign removed because we want the modulus only. Understood? This is about potential. Now the difference between the field and potential is, potential energy is a scalar quantity. Let me write it for you. Potential energy is a scalar quantity. That's why we were not, when I try to find out the potential energy of a system of mass, I did not try to add them. I did not try to add them vectorially. I have just added them scalarly, quantity wise. Because potential energy is a scalar quantity, that's why the potential which is represented by V at a point is also a scalar quantity. But if we talk about this force and field, force and fields are actually a vector quantity that you should be very careful about. Whenever you are trying to add force or field, you have to do them vectorially, means by resolving the components. By resolving the components and then adding them vectorially, taking the resultant, resolving the component, then taking the resultant. And when you are adding the potential energy or the potential you want to find at a point, you just add them scalarly. Clear? Concept is clear? Acha. Can you give me the result for this one? I'll give you a question. Find potential at center of square when mass of 1 kg is present at each corner. and side length is let me say it's 2 centimeter or 2 meter. So what your system is like this. The system is like this. There are 4 masses, 1 kg, the distance is 2 meter, it's a square. You have to find out the potential at the center O. Try to do it. This is the question is made by me.
So is it
Hmm?
minus 2 root 2g?
Minus 2 root 2g you are saying. Let me check. 1 root 2 root 2g 2 3 4 2 root 2g. Correct. Your answer is correct, but you need not put minus sign here, because I said na potential is a scalar quantity, and that too when we find out the potential we are just concerned with the magnitude only. That's why we take actually the scalar. The potential energy is negative. Potential energy has negative sign associated with it, but potential is positive always. Okay. Clear, Haripriya? What about you, Kanishka? Do you want me to solve it? It's easy only. See, this distance actually we want to find, so we need to find this distance. This one. The distance of each mass with the center. So this distance is 1 meter. Half of this is again 1 meter. So this will be √2. So there are 4 different masses. You need not have to take 2 mass combination here, because at O we have to find. So there are 4 masses, each at a distance of √2 unit from a center. So it will be G minus G into 1 kg divided by √2. This you have to multiply with 4. Like this only you did, na? So √2G. Acha, Haripriya, can you give me the result for one corner? Potential at one corner. What would be the potential at one corner of this square mass system?
Well, would it be GM of 1 plus 2 by 2?
Plus 2 √2. No. 1 plus 2 √2 by 2 √2 you said, no? No, one mistake. It should be G into 1, 2G plus G by 2 √2. One plus 4 √2 by 2 √2, if you have said it was correct. You said 1 plus 2 √2 by 2 √2.
So what about the distance for the other two? It would be
For sorry. sorry, it's 2 meter distance, na? Okay. Sorry, my mistake. But then also different answer will come.
your
Oh,
2 gets cancelled.
no. You are correct, I think. 2gm by, I have done one mistake. 2g by r is 2 units, na? 2 gets cancelled. Correct. You are right. Very good. Unnecessarily, I was getting confused. Very good. You understood the concept. For 2 masses, for the above mass 1 kg and this 1 kg, the distance is 2 unit. So it will be 2 in twice of g into 1 by 2. That's 2 getting cancelled. Plus for the third mass, this 1 kg mass, distance is 2 √2. So g by 2 √2. That's very good. Okay, now in the next class, I'll teach you about the motion of satellites. Motion of satellites, orbital velocity, escape velocity, binding energy, and then your Kepler's laws. Then I'll tell you how the advanced questions are formed on this and how to solve the advanced question on this. There is actually two concepts only using which you will be solving the advanced question. One is law of conservation of angular momentum, which you will be learning in Kepler's law, and other is law of conservation of energy. All gravitation questions are are solved using those two only. Law of conservation of energy. Let me write here. Conservation of energy and conservation of angular momentum. Both of the things you know. All gravitation problem. Let's end it. Okay, bye bye. Good night.
Bye.
Bye. Bye bye.